Most people think smart manufacturing and Industry 4.0 are about futuristic factories full of screens and robots, but the truth is much simpler. Industry 4.0 exists to make machines observable, measurable, and improvable in real time. Traditional manufacturing relied on periodic checks and human experience. Smart manufacturing turns machine behavior into continuous data. To see this clearly, imagine a simple everyday situation where you use Google Maps while driving. Instead of guessing traffic conditions, you see live congestion, predicted delays, and alternative routes. Without realizing it, you're relying on the same logic as Industry 4.0, real-time data guiding better decisions instead of intuition alone. What's actually happening here is straightforward. IoT sensors collect data from machines, data analytics identifies patterns, and engineers use those insights to improve performance, efficiency, and reliability. Sensors measure vibration, temperature, pressure, speed, energy use, and quality metrics. Analytics turns raw data into actionable insight. Now imagine a real factory scenario, a CNC machining line producing automotive components. Sensors are installed on spindles, motors, and cutting tools. They continuously monitor vibration, temperature, and power draw. Data analytics reveals that tool wear increases sharply after a certain vibration threshold. The system alerts engineers before surface quality drops or tools break. Feed rates are adjusted automatically, scrap is reduced, and unplanned downtime disappears. Nothing is automated blindly. Engineers define limits, interpret trends, and approve changes. Data doesn't replace judgment, it sharpens it. This same logic operates across modern manufacturing. Production lines self-adjust based on demand. Energy usage is optimized in real time. Quality defects are detected earlier, and maintenance becomes predictive instead of reactive. Mechanical engineers move from firefighting failures to designing stable, efficient systems driven by data. The Industry 4.0 concept was strongly advanced through industrial leaders like Siemens, who integrated sensors, automation, simulation, and analytics into unified manufacturing ecosystems. This transformed factories from isolated machines into connected systems. In practice, smart manufacturing follows a clear workflow: sensors, data acquisition, analytics and dashboards, engineering decisions, machine or process optimization. The factory doesn't become autonomous overnight. It becomes transparent, and transparency is what enables improvement. Now that you understand the intuition behind IoT-enabled smart manufacturing, the next natural step is to explore AI-driven quality control and defect detection, where vision systems and data models identify problems humans miss. And that's exactly what we'll break down in the next episode.